Okay, last part for chapter 5, which is we are going to see the last application, which is the intersection between a line and a plane. So here, as you can see from here, so we have a plane. Here is plane, which is, let's label that as P1, and we have a line here, and let's label that as L1. So the point of intersection that we want to find here is this point here. Okay, so that is the point that we want to find. So basically what you have to do here, okay, we put the equation of the plane, which is r dot n equals to a dot n. Okay, vector equation of a plane, and we have the Cartesian equation of a plane. So this is the vector equation, and we have the Cartesian equation of a plane, which is ax plus by plus cz is equals to, let's put as d as the constant. This is the Cartesian equation of a plane. And we also have the equation of a line. So for L1, which is the vector equation of line, we have r equals to a plus tv. Okay, what we need here is actually the parametric equation of a line. So this is the vector equation, and we need to find the intersection point, we need the parametric equation of a line, which is x, y, z as the subject. So here we have x equals to a1 plus tv1, y equals to a2 plus tv2, z is equals to a3 plus tv3. Okay, so this is parametric equation of line. Okay, so what you need to do to find the point of intersection, so there are few steps that you have to follow, which is the first one is we are going to substitute PE line, parametric equation of line, into CE plane. Okay, so what we need here is parametric equation of line and also Cartesian equation of plane. So here you have x, y, z, so we are going to substitute into x, y, z here. Okay, if you substitute the value of x, y, z, the equation x, y, z, you are going to get the value of t. So we are going to find the value of t. And lastly, we are going to substitute the value of t that we have found into sub t into PE line. Okay, so if we get the value of t, we are going to substitute back into PE line to get the value of x, y, z, which is that will be the coordinate that we want to find. So let's go to the example here. We have example 37. Find the vector equation of line passing through the point 312 and perpendicular to the plane. Okay, so that is the first thing that we have to find. We have to find the vector equation. So let's draw the diagram. We have a plane. Okay, we have a plane, and we have, this is the plane, and we have a line that is perpendicular to the plane. Okay, there is a line perpendicular to the plane. So let's say this is your plane 1, this is your L1. Okay, so the question asks us to find the vector equation of a line. So we have r is equals to, this is for L1, r is equals to a plus tv. So what do we need here is we need the vector and we need the point. So the point, we have it here, 3, 1, 2. So the vector for this line here, since we know that the line is parallel to the normal of the plane, okay, we do have the normal of the plane which is also perpendicular to the plane. This is the normal, so we can use this normal as the vector here. Okay, so the normal for this plane here, we have, this is your equation of plane, r dot n, okay, equals to a dot n. That means this is our normal. Okay, so what we have to do here is just substitute. We have r is equals to, a is the point, 3i plus j plus 2k plus t. V is the normal of the plane because it is perpendicular to the plane. So here we have the normal 2i minus j plus k. Okay, so that is the equation of a plane. Sorry, equation of line that we want to find. Okay, vector equation of line. So the question asks us to find the point of intersection between line and plane. So this is the point that we want to find. So back to the first step, we are going to find PE line and CE plane. Okay, so we need PE line and CE plane. So let's find the PE line first, which is, this is your vector line. So to find the PE line, we have x equals to 3 plus 2t, y equals to 1 minus t, z is equals to 2 plus t. Okay, so put this, all of this thing as first equation. Okay, so the next thing is we want to find the Cartesian equation of plane. So here is vector equation of plane. So for plane here we have P1, we have the vector equation r dot 2I minus j plus k is equals to 4, but we need the Cartesian equation. So here we have 2x minus y plus z equals to 4. So this is the Cartesian equation of a plane. Okay, so what we need to do, let's put this as second equation. So now that is your first step. Okay, that is first step. So the second step is that is the first step, which we have to substitute PE line into CE plane. Okay, so here we have the first step, which is we have to substitute all this into here. So now we will have 2x, which is 3 plus 2t, minus y, 1 minus t, plus z, 2 plus t is equals to 4, which is we are going to find the value of t here. So here we have 6 plus 4t, minus 1 plus t, plus 2 plus t equals to 4. And here we have 4t plus 1 plus 1, we have 6t is equals to 3, and we have t is equals to 1 over 2. Okay, so that is your step 2, which is to find your t. Now if you have your t, we go to the third step here. We are going to substitute t back into the parametric equation of the line. Okay, so now we have x equals to 3 plus 2 times 1 over 2, which is here we have 2. Y is equals to 1 minus 1 over 2, we have 3 over 2. And lastly, z is equals to 2 plus 1 over 2, which is we have also 3 over 2. So now the final answer, make sure to write in coordinate form. We have point of intersection between line and plane is equals to 2, 3 over 2, 3 over 2. Okay, so as simple as that. Just you need your parametric equation of line, you need Cartesian equation of plane, substitute this into this, you'll get the value of t, substitute back your t into parametric equation of line. Okay, so let's do one more question here. Find the point where the straight line, here we have the straight line here, okay, intersect the planes. Here is our plane. Okay, so we need PE line, we need CE plane. Okay, so let's do the line first, which is given to us r equals to negative 4i plus j plus 9k plus lambda negative 2i plus 4k. Okay, so we need PE line, so put this as x equals to negative 4 plus negative 2 lambda. Sorry, that minus 2 lambda. Okay, make sure you know that your r is actually x, y, z. Okay, so that's why we let x here. So y is equals to 1. So here you don't have your j, 0j. So just leave it like that. Y is equals to 1. 1 plus 0 lambda, that means 0. So here we have z is equals to 9 plus 4 lambda. Okay, so that is our PE line. Okay, so this is first equation. So next we have to find the Cartesian equation of plane, which is for plane here we have vector equation r dot 2i plus 2j minus k equals to 5. Okay, the same thing here, your r is actually x, y, z. So that's why we have 2x plus 2y minus z is equals to 5. Okay, so this is the second equation, this is CE plane. Okay, now go to the first step, which is we have to substitute PE line into CE plane. Okay, so we have 2x negative 4 minus 2 lambda plus 2y, which is y here is only 1, minus z, we have 9 plus 4 lambda equals to 5. Okay, so on your left hand side we have minus 8 minus 4 lambda plus 2 minus 9 plus 4 lambda equals to 5. Okay, so here we have negative 8 lambda equals to 20. Lambda is equals to negative 5 over 2. Here should be negative. Okay, negative 9, negative 4 lambda. So here we have negative 4 lambda, negative 4 lambda. Yep. Okay, so that is your second step, which is to find t. But for this question, we want to find the lambda and a constant actually. So to find the point of intersection, just we are going to substitute back the lambda into your PE line. Okay, so here we have x is equals to negative 4 minus 2, negative 5 over 2. Y equals to 1. So you don't have to find coordinate of y. Z is equals to 9 plus 4, negative 5 over 2. So here's gonna be negative 1 and here's gonna be equals to 1. Okay, make sure to write the final answer. Point of intersection is 1, 1, negative 1. Okay, so very easy. 1, 1, negative 1. Okay, so that's it for vector chapter 5. So this is your exit ticket for both of these video angles and point of intersection. So I'll see you guys in the next chapter. Alright, thank you guys.